I'd like to start with this beautiful paper by Brian Cantwell Smith. So Brian is kind of a philosopher of computing. I mean, he was working at Xerox PARC in the golden years of Xerox PARC in the end of the 70s. He wrote this paper in 1985, and I invite you to read anything this guy touched. He has some really nice books, but this is in particular a very nice paper. He was writing to a conference about the Cold War and the nuclear threat and so on. And he's talking about the correctness. So this was the first wave of enthusiasm about formal methods and verification. And he writes this beautiful paper. And I'd like to highlight some of the main points he makes here. He says, I've chosen to look at modeling because it exerts the most profound and most important influence in the systems we build. To build a model is to conceive of the world in a certain delimited way. It is with respect to these representations that computer systems work. They run by manipulating these representations. This can all be summarized in one slogan: no computation without representation. It's good to remind us of that. And then he says, mediating between the system and the world is the inevitable model. What we have been focused on as a discipline is the study of the relationship model system. What about the relationship model world? At this point in intellectual history, that was 85, but it's still the case, we have no theory of this relationship. Any adequate theory of system correctness will have to take the model world relationship into account. So correctness requires that we understand the model world relationship, right? Computers are just a symbol manipulating machines, but then which symbols? What do these symbols mean in terms of real things in the world? Real relationships, real events, real objects, real relations between events and objects and among events and so on, right? This is so-called real-world semantics. So this is a talk about the model-world relationship and the impact that it has in software design and development. So we start with three very uncontroversial observations. So the first one is this: a software system embeds a representation of reality according to a particular worldview, the inevitable model. No computation without representation. So, in fact, any information artifact, which is not just a piece of mathematics or something that has what is called real-world semantics, this thing makes an ontological commitment, right? So we look at this is a subway map of Amsterdam.